I think we're live. Hello, everyone. Kyle, A0Z. Look who I got. Oh no, on that side. No, on the other side. No, the other side. Hey, George.
Hey, Kyle.
KJ6VU. Hello. How are you?
I'm doing great. How are you?
Good. And we've got Mike Walker, VA3MW. Hello, Mike.
Good. And I know somebody's going to tell the story about what's going on here at some point in time. Thanks for having me. He literally got the invite. I invited myself, 148 seconds ago.
He did. He sent me a text. He's just like, I want to be invited. I'm like, okay. And then he showed up and then we were working through audio issues. So anyway, hello, everyone. Appreciate everyone in the chat and everyone showing up, everyone that's going to watch this after the live. What we're going to do is, George, you have come out with an amazing product. It is the station controller. And in full disclosure, George, I was lucky enough to be on the beta program, and Mike was on the beta program. So in full disclosure, I did get a station controller for free, and it is installed in the shack. And I want to go over the station controller from a high level overview. But I think what we're going to do, George, if it's okay with you, is kind of do a deep dive on some of the things that you didn't talk about on some of the other channels. So if you take a look at Josh, HRCC, Ham Radio 2.0, Jason, and Mike K and MRD, and who else did you do an interview with? Do you remember?
Those are the three, mainly those three.
Three main ones. Yep. Go to their channel and you can watch that overview of all the things that the station controller will do.
European Ham Radio Show with Morton and the team.
Oh yes, Morton. Yes.
That's right.
Yes. Go over to their channels and watch the overview if you want an overview. But I think what we're going to do is we're going to do a deep dive on like connecting all of the devices and the DCN network and some other things. So we're going to get into the weeds here. I've got my nerd glasses on. So we're going to get into the weeds. But first, what I want to do is, I know everyone is itching. We're going to get this done at the very beginning of the show. How do you buy one? Let's go there and figure out, how do you buy one?
That's a great question. Thank you for doing that first. So the company is called Sierra Radio Systems, and it's a company I've had for a long time. We've made control systems in the past, mostly repeater controllers and other related stuff. And if you go to sierraradio.net, then you can find all of the control systems and you can buy through the web. And I also have a company called Pactena, which is really just part of Sierra Radio Systems. And Pactena is portable HF mostly and some VHF ham radio gear for us portable operator types. And those are two really different things, but they're both hosted on the same website. So go to sierraradio.net and go to the shop and you can find all of these products we're talking about.
So if I go over here, let me change my screen here. So if I go to pactena.com, if I go there, it's going to bring up this website, and Sierra Radio Control Systems is going to be front and center. We click on here, and this is where we can click on the station controllers, and this is where you can order it, correct?
Yeah, so this is all the product information on the web page. Up at the top, if you scroll down, you'll see more information about the products. But if you go up to the very top on the nav bar, there's shop right in the middle. If you just mouse over that, then you can just click controller shop. Once you click on that guy, then this takes you to the three different departments in the shop. The first one is the actual control modules themselves. That's the system, are those. And then there's a bunch of accessories that you can get, like connectors and cables and relays and stuff like that. And then there's some odds and ends, bits and pieces you can also get, and that's in the parts section at the bottom.
Yep. Okay. Very good. So we've got that out of the way. I know that every time that I do a stream about a product, I always get like people in the comments or them emailing me, how do I buy this? And it's all in the show notes, but people don't read the show notes, and I understand. But so we're going to get that out of the way on how do you purchase a station controller. That is out of the way. We are done now. So what I would like to do is let's just do let me remove this and let's go back here. Let's do a 5-minute overview of the station controller and just kind of do a debrief on what it does and what does it solve.
Sure. So the station controller basically allows you to remotely control and monitor equipment. And it's tailored for radio equipment. And the most typical use case that it's designed for is for those of us who want to run, let's say, a remote HF station. So let's say I've got a Flex or any any brand of HF radio gear. You have a remote station, you've got the radio, you've got a power supply, you've got an antenna, you've got an internet connection to get to it. And the radio manufacturers like Flex solve the problem of remotely controlling the radio itself. So you can change the frequency, change the mode, you can change the RF power output, you can shuttle the audio back and forth. That's all a solved problem that the radio manufacturers have solved. But that's not the whole story. So in addition to that stuff, what's left to the operator to figure out is, how do I control and monitor the stuff that sits around the radio? And so what would that be? And the most simple example is that you want a way to remotely turn your station on and off, not only for safety reasons, but also for legal reasons. Because if you have a remotely controlled transmitter, you need a way to positively control it. You need a way to at least shut it off so you can't cause any interference. But there's a lot of other things you'd like to do. You'd like to turn other equipment on and off. You'd like to switch between different antennas. You'd like to measure the RF power at your station all remotely. Maybe you want to monitor the temperature of your amplifier. You want to monitor, some other, DC power supply or batteries or your solar panels. So all that stuff could be controlled and monitored with the station controller. And then the station controller could also be used for other stuff too, besides an HF station. So they're also used for controlling the environment at a repeater site. So as a repeater owner myself, I want to be able to control and monitor the stuff at my repeater site besides the repeater itself. So I want to look at the RF power going to the antenna and reflected back from the antenna. I want to be able to turn an amplifier on and off. I want to be able to monitor my backup batteries if we lose AC power. All that kind of stuff could be done with the station controller as well.
Yeah. And it's got different modules. So today you have what, 4 modules that?
Yeah, there's 4 main modules. So the heart of the system is a computer of some kind. It could be a Raspberry Pi, or it could actually be virtually any computer. To make things easy, we make one module that hosts the Raspberry Pi itself. So on this picture here, that's the lower left-hand image. So you can see that the Raspberry Pi there is mounted to a board, standing by.
Hang on. Where?
Yeah, there we go. So the lower left board is a Raspberry Pi, and it's running Linux, of course, and it's running the dashboard control software written in Node-RED, which is open source. So that the reason why we have a module is to make it easy for people to buy a turnkey solution. So when you get that module, it comes with the Raspberry Pi, it comes with the SD card pre-formatted with all the software on it. And it's designed to work in a ham shack. So you can see a power pole connector, for example. So you can run, a 12-volt battery or your power supply into the power pole connector or the barrel connector. The power supply is all built in, and that runs the Raspberry Pi. And also it provides connections to the other modules. So those little black connectors that look like RJ45s, which they are, those are the connectors that go to the various control modules. And the Raspberry Pi host module can support up to 3 external modules physically. Electrically, you can have as many as you want on the network, but there are 3 connectors, so it supports 3 modules. You might also notice sort of an odd addition to that. In the upper left-hand corner, there's a little tiny white circuit. Nope, on the Raspberry Pi board.
Oh, on the
there's
Raspberry Pi.
There's a little circuit board with a display on it and a tiny antenna above it.
Oh yeah, right here.
And that's actually a Meshtastic radio. It's a Heltec V3 Meshtastic. You don't need to use Meshtastic at all with it, but there's some applications where you want to remotely control something farther away, and you could do that over a Meshtastic network. So that's the core. By the way, if you have your own industrial PC or any PC really, you can take the Node Red dashboard, install it on your PC, and then use a simple dongle that connects from your USB port on a computer to the network, and you can run everything off of whatever PC you already have. So we supply the Raspberry Pi module really as a convenience more than anything else, because it's tailored for the application.
Right.
So George, there was a question, because I actually think I asked you this. So doing what you just said, I could use my own compute module?
Oh, yeah, 100%.
Yeah.
Yeah,
So,
all you need is a little $10 dongle that just converts the USB connection to an RS-485, which is what the interconnection scheme is between the different modules. So yeah, you can use any computer you like.
And the great thing is all of this runs on 12 volts, which is great, because one of the caveats of putting a Raspberry Pi in your shack is, how do I convert my 12 volts down to 5 volts and power my Raspberry Pi? And you have solved it.
Yeah, exactly. And now there's many ways one could solve such a problem, but it's that sort of thing, Kyle, that I really put a lot of thought into about how do you make this thing so it's really tailored for a ham shack. So the power supply that's built into the RPI module there will take anything from about 10 volts to about 18 or 20 volts and power the Raspberry Pi, and then also route that power out to the network. So those Cat5 cables that, or in this case, Cat6 cables that interconnect between the modules, those cables supply not only the data, but they also supply the 12-volt power bus to the other modules. So you don't have to power all the modules individually. You just power one, and it distributes the power to all of them.
Yeah.
They're Ethernet cables, but they're not Ethernet cables.
Yeah.
Yeah. So we can drill into what exactly that wiring is.
Yeah, we will. Yep. Okay, and then we've got this, basically it's a distribution block.
Yes, so it's a passive hub. So what that does is it takes the 8 wires on the RJ45 and connects multiple connectors together, and including, this is a prototype picture here. The production one has a terminal block also on it. So you can also go to twisted pair and provide other twisted pair power as well as data. In this case, with 3 modules, you don't need that block because the Raspberry Pi already has that a 3-port hub built into it. So you wouldn't need that. But if you have more than 3 modules, then you need some way to split that into multiple cables. So the splitter gives you 5 ports plus screw terminals, and you could daisy chain them. You can have as many as you want.
And you can inject power into the distribution by getting an Anderson power pole with some right angle connectors and soldering them into the distribution panel right there.
That's right. So a simple way to think about it is every module, the Raspberry Pi module, the hub, all the control modules, everyone has a 2.1 millimeter barrel jack and screw terminals that you could apply 12 volts into. Yeah. And as long as you put 12 volts into one of those ports on one of those boards, the Cat6 cable connects them all together and supplies power to everything. Yeah. So you only need one point where the power comes in. So the hub's a good example. You can just jack into the hub with your power, and then that'll take it to all the control modules.
Yeah, that's what we did at the contest station. Is we had, we have 2 Raspberry Pis with NVMe drives that run everything. Our amp rack, our rotor controllers, everything, our antenna switches. Then we have another Raspberry Pi that does all the Node Red stuff. Mm-hmm. And we have just run 12 volts now to everything. And everything in the rack is now 12 volts. We don't have any 5-volt power. We just have AC and 12 volts, and it's great.
Yeah, so all these modules run off external 12 volts. Yeah. So even though the processors are 3 volts and there's some logic that's 5 volts and there's some like relays that are 12 volts, you supply 12 volts to it, and they all have their own built-in power supplies. Yeah. So that keeps the wiring fuss and muss to a minimum. And having power jacks on everything means that you can plug in one place, get the power to everything, and it really minimizes the amount of cable mess.
Yeah. And whenever you're dealing with your shack, a contest station where you're trying to get the lowest noise floor as possible, getting all of that RF, getting things that create RF out of your shack is a good thing, because you want the lowest possible noise floor so you can hear the signals. Yeah. You can hear them, you can work them, right?
It also, and that's especially true to keep you from inducing noise on yourself, There's also the possibility in a high RF environment that you're going to induce RF into the control system. And so minimizing the amount of interconnects means that if you have to choke something, you can choke one of the cables. You don't have to choke 10 things.
Right.
And hopefully you'll solve that problem if you do run into any issues like that.
Right. Let's go over the rest of the modules, and we've got some questions in the chat here that we're gonna get to. You want to start down here with the Wattmeter?
Yeah, so there's three modules, three control modules. There's the general purpose I/O module, an antenna switch relay module, and a Wattmeter module. So, well, while we're here, let's just start in the upper left.
Okay.
So the upper left here is the GPIO, or general purpose I/O module. It's got 18 channels of input or output to monitor or control things. Along the bottom, you see the terminal blocks. There's 4 terminal blocks. The first block are for 4 DC voltmeters. They'll each measure 0 to 50 volts DC, chassis ground, common system ground referenced. So there's 8 connections there. Each pair is for a voltmeter. So it's voltmeter 1 ground, voltmeter 2 ground, voltmeter 3 ground, and so forth. The next block over is a open collector output for up to 4 relays, and those pairs are open collector and 12 volts, open collector 12 volts. So if you're going to connect to a large external relay, like a power control relay, you just take a pair, a zip cord, 2-wire piece of zip cord, screw it into 2 terminals. You now have power and the ground side, the open collector side, run that to your relay and you're good to go. It's designed to work with a 12-volt relay, so we provide the 12 volts, and it includes the reverse diode clamp on those devices, meaning you don't have to have a diode across the external relay. That's already compensated for in the controller. The next block over are 4 small signal single pole, single throw relays. So of those 8 terminals, there's 4 pairs of contacts, dry contacts, and you can see the little relays, those little white cubes on there.
Yep.
Good to 2 amps, so you can put any signal through those built-in relays. And then the last terminal block on the right are digital inputs. So you have the active input and ground for each of for 4 channels. So when you pull the active input to ground, then that channel goes active. It registers that it's on to the internal software, to the dashboard. And those inputs are all opto-isolated. So they're clean signals coming in. You don't have to worry about ground loops and noise and stuff. Along the top, from left to right on the GPIO module, that connector there, that's called a system connector. Most of the modules have it. This is really an optional connection. It provides 12 volts DC input and output, and it provides extra data pins for the data network in case you want to use twisted pair connections. So normally you don't need it, but it's there in case you do. Next to that is a USB-C jack. That's the console jack. This normally you don't use this in normal operation. The console jack is where you would either flash new versions of firmware, or there's some functions which you might want to customize, and that jack gives you access to all the internal commands to customize the behavior. So for example, if you want to change a label on something, you can go through that jack and type in a command, and it'll change it for you.
Yeah.
Then there's 2 little green terminal blocks. Those are for temperature probes. We use 18 B20 digital temperature probes, so you can put them on wires up to about 20, 30 feet long. It's a little metal capsule. You don't need to calibrate it. It's not a thermocouple, so you don't have to calibrate them at all. You just plug it in and it works. Next to that is the 12-volt DC barrel jack. And then next to that is is what we call the DCN, the device control network jack. And we just talked about that. So that's the data and power routing around to the different modules.
Yep.
One last little thing too, on all the modules, if you go down to the lower right-hand corner, you see a bunch of LEDs. Those LEDs tell you the status of that module. So there's a status LED, there's a string of LEDs that'll tell you what's going on. So when the board is running, when it's powered up, it's constantly scanning all of the inputs. And you'll see the LEDs race because that'll indicate that it's going through its control loop to grab all the inputs. And then in the middle, you see an LCD display. The LCD display rotates through updating you with the values of various inputs. So what are the voltmeter inputs? What are the digital inputs? What's the relay state? And if you want to put this somewhere like in an equipment closet and you're never going to look at it, that display just unplugs. So there's 16 little header pins that hold it in place. And if you don't want to use the display, just unplug it. And it, you don't have to do anything, just unplug it and it runs fine.
Yep.
So that's kind of the tour around the GPIO. The board to the right of that is the HF 6-meter coaxial relay. You notice that on the bottom there's a bunch of solder pads with nothing on it. So this is a prototype picture. This is the prototype. What you'll see on that module, we'll flash a picture here in a minute, is a row of BNC connectors. And so we use right angle BNCs that point down when you look at it down from the top. So this is really a design to allow you to switch one radio to 4 antennas or one antenna to 4 radios, depending on what you're doing. And all of the interconnect is all done with latching relays. And so if you lose power, the configuration will remain intact. So if you pick antenna 3 and then power goes out, it's still on antenna 3 whether you have power or not going to the station. So when you select a given port, the controller will deselect the last port, pause briefly, and then connect to the new port. And of course, that delay is programmable. So the idea there is you can never have more than one port active at a time.
Let me, yeah, go ahead, Mike.
If I maybe George wants to elaborate, or I can, but the whole latching relay thing and why on my station I never put relays right on the Pi itself. Well, it's a great idea, but the minute the Pi bumps through rebooted, all your relays shut down and your whole ham shack exploded. Didn't explode, but everything went, turned off. And that's why I've always had external web relays. And George heard my dialogue when I saw this, and I went, okay, all my external web relays are going. And because of that latching effect, which is, so critical. I know, Kyle, you've been through that more than once, right?
Yes. So here is the let me
That's
see if
cool.
I can zoom in on here. So this is our relays, our boards at the contest station, and you can see I can't really see very well, but we have 2 relay boards, and you can see the right angle BNCs here. I just ordered from DigiKey a 50 ohm terminator that we're gonna terminate this third one, but you can see there's 4 there. So it's 4 latching relays, and then the common is the middle relay. Correct, George?
That's right.
So we have 2 flexes at the contest station. We have a 6700 and we have an 8600. So what we have done to run SO2R on either one of those, we have wired in all of the A antennas to this relay, and we've wired in all of the B antennas to this relay, and then we've got the third relay open, and then the 4th relay goes to a dummy load. So that's how we've got it connected. And you can see the Pi up there with the NVMe hat on it. Well, it's a bottom hat, but that's our Raspberry Pi, and then we've got the distribution here. So that's the top part of our rack at the contest station.
So a couple of things I think are worth mentioning in addition to that. So you can see on
full. Yeah,
you
go
can
ahead.
see
Sorry.
on your picture there, you can see the DIN rail mounting bracket. So one of the things I didn't mention is that you could mount these boards in a couple different ways. You can mount them like any printed circuit board. There's holes in the board. You can mount it on standoffs, however you like. But I thought that using DIN rails made the most sense. It's the easiest thing to wire, in my opinion, and modify in the future. So DIN rail is a extruded piece of aluminum about 1.5 inches wide, and there's clips on the back of the modules that snap onto that. So every board, there's a base plate that insulates you from anything below it, so nothing shorts out. And the clips just snap on there. And so it's very easy to swap out the modules or move them around, and it's easy to get to the wiring.
Yeah. If you don't know anything about DIN rail, go do some research on DIN rail. It is amazing. Whenever I worked at Anheuser-Busch many years ago, all of our PLCs, all of our control relays, process control were all mounted on DIN rail, and that's where a new engineer college grad out of college was like, "What is this new type of technology that we're snapping this is dead rail. I'm just like, this thing's freaking awesome.
What's really cool about it is there's a gigantic ecosystem. So for example, here is a super skinny relay.
Yeah.
So this is a single pole double throw relay, and you can see on the back here this little gap. That's where it snaps on that DIN rail, and then there's screw terminals along the top and bottom, and there's a status LED, and you could pack a whole mess of these things together, and so like some things like this I sell, but you can go on, on Amazon or whatever, and you can find there's power supplies, there's distribution panels, there's voltmeters, there's like tons of things, because it's all, like you're saying, Kyle, it's all part of that industrial automation ecosystem. So you can find plenty of professional gear out there.
Yeah. There's a few questions in the chat here. Oh, where are they? Guys, where are they? James says, can I highlight this? Why can't I highlight this? Please, OBS, can you please behave? James says, inside air at the repeater. I think he's talking about the temperature probes. Yeah, you can monitor anything.
Sure.
Yeah.
Yeah, the temperature probes, they're a little metal capsule about an inch long and about maybe a quarter inch in diameter that has the temperature sensor in it. And then there's 3 wires that come off the back. And we have those in the accessories in the store. And you could add extra wire to them to make them much longer, even than the 3 to 6 feet that we have. And basically, you just put the capsule somewhere. You can tape it to the PA. You can just let it hang in the room and get ambient temperature. You can leave it in the rack. So for a repeater station, what we do is we have one temperature probe outside the building. We have a temperature probe for ambient air inside the building. We have one inside the cabinet. And then we also put one in front of and behind the air conditioner blower. And the reason for that is, obviously, we want to know what the temperature is in the rack if something's too hot. But we can see how well the air conditioner is working. And it often was the case that the air conditioner at the repeater site would poop out. And so we can see the temperature differential between what goes in and what comes out.
Yeah.
And if it's like 1 degree or 2 degree different, there's something wrong with the air conditioner. So you know what's going on. And so the spirit of all that is, if you've owned a repeater that's not easy to get to for a long time, you really come to appreciate the ability to measure what the heck is going on. So when you go to fix it, you know what the probable problem is before you drive up there, just to realize that, oh, I should have brought a replacement, filter or whatever I needed.
Yeah, good.
I have my PGXL. If you've seen my cabinet, it's all pretty tight. And I monitor the temperatures like George says. I have an in, which is pretty cold today, but I'm amazed running the Power Genius at full power with literally 4 inches all around it, and I force air through the cabinet, that it doesn't get that hot. I might see it get to 35 Celsius, and that sounds hot for you and I, but it's quite acceptable. And
Mike, do you put a temperature probe right on the amplifier, or do you just read the air that's running around it?
I'm fascinated by temperature, so I have probes everywhere. But the Power Genius has 2 probes in it, so I know how hot the 2 heat sinks get. But I just have it sitting in the airspace behind in the free air, where you'd open it up, stick your hand in, and go, wow, it's really warm. It's warm, but it's not nuclear hot. And then I have multiple shelves, so I have like the Power Genius shelf, and then the equipment shelf above. And the air flows up and out because heat rises, so I usually work with it. What I learned from that is, if you keep the air moving, you're good, type of thing. And like you, I have alarms if they go off. But it's been a 20-year exercise in going, it's not as ugly as we all think it is. It's not like I'm doing 1,500 watts key down RTTY for 20 minutes.
Yeah. Mike, you have the fortunate to live in a area that 9 months out of the year it's like a data center.
Yeah.
You're going to start implementing hot aisle, cold aisle here in your ham shack.
Well, we do get calls though that people from Texas or whatever, and I just want to put it in the garage, and what's too hot, and I'm like, well, you're just gonna have to try it and keep an eye on it. But generally, if you keep the airflow moving, you're at least halfway out of the game.
Yeah. Jody says or asks, any thoughts about a carrier board for a Raspberry Pi compute module like a CM5? Just thinking a bit lower power consumption option, maybe even with add-on components like Ethernet, etc.
Yeah, so that's a really good question. I decided to go with the conventional Raspberry Pi footprint for as the first one, and maybe the only one. The reason being, first of all, it's everybody's got a Raspberry Pi sitting in a drawer somewhere, and if I figure, well, maybe you just want to use your own Raspberry Pi, and that's fine. It turns out that if you compare the power consumption between the Raspberry Pi 3, 4, and 5, they progressively consume more power, the 5 particularly. And I think the sweet spot is Raspberry Pi 3. The 2s will work, but they're kind of slow. And I would just not bother because you can buy a brand new Pi 3 for $35. So, why not? And you don't need a 5. I mean, you could do that.
We have two
done it.
Yeah, with SD hard drives. So
Yeah, so there's a little bit of temperature there, a little current consumption. So I mean, all that stuff will work perfectly fine. So I didn't do the compute module because of what he was alluding to. There's no network, physical wired network built into the compute module. You have to provide the Mac and the Phi and all that jazz. And it was just like more complexity, and all that stuff is built in 3, so why not just use the 3?
Yeah.
Now, having said that, I'm sure there's other people who will want to not use a Raspberry Pi. Like, for example, I've got a industrial PC that was made by Lenovo. It's a point-of-sale computer, basically, and it's got big heat sinks, and it runs off of 12 volts, and it's meant for like a cash register or something, to like run forever. So that would make a great industrial computer for something like this instead of the Raspberry Pi. But if you go buy those things brand new, they're really expensive. So that's really not something I can sell. So I needed to find something that was perfectly up to the task and drew as little power as possible and was inexpensive. And the Pi 3 kind of fits that bill.
Here I am. I'm back.
And by the way, the three just loafs. It's not even busy.
Yeah.
So when we're running, looking at, if you do top and you look at the activity in Linux, the Node-RED dashboard that we supply as the starting point, the stock dashboard, takes somewhere between about 5 and 10% of the CPU cycles. So it's pretty minimal.
Yeah. You want to go to the let me add this to the scene here. Where did we leave off? We left off on the.
We talked about one more thing on the coax switch thing.
Yeah.
Well, actually 2 points. One is it's designed for HF, so it works perfectly fine. HF and 6 meters, 100% within spec. I also checked it out on 2 meters in UHF. Now, I don't say it's a 2 meter coax relay, but it turns out it's not horrible on 2 meters. If you designed this for 2 meters, big mistake. It's really not. It's not good enough to say it's a VHF coax relay. I actually have a different product in development for that. So we're going to do a 2-port VHF UHF controlled impedance RF relay for VHF stations. But in a pinch, you could use this on 2 meters if you absolutely had to, but it's awful at UHF. So it's really an HF and 6 switch, and it's rated for 100 watts. And right now, one of our beta testers is running like 300 watts through his, and he said, "Well, this thing handled 300 watts." I said, "I don't know. I don't have 300 watts. Give it a try." So we're gonna find out.
Maybe next weekend during the contest, maybe we'll put 800 watts through it and see if it's.
Yeah, it makes you have a spare, like a fuse. You can pop another one in there.
Don't do that the weekend before WPX. How about that?
No. Yeah. So one other thing is, before I built this out as a remote station control thing, I had an application for just this coax relay in my normal sit in front of it station. And that is that I have multiple radios in one antenna that I normally use for my home station. And I wanted to be able to switch between different antennas, and I want to use my Stream Deck for that. So I have an Elgato Stream Deck, And so I wrote a little piece of software that will take a key press from a Stream Deck and generate the right command codes to tell the antenna relay to switch between radios. And that works great. And so that's not even a remote control kind of application. So I think, like, there you go. I think, like, for me personally, I probably use my station controller more as just a station automation system
Yeah.
than for remote access, although remote access is kind of the big goal. But once you've got it, then you find a bunch of other uses for it just to make it easier to operate the station.
Oh,
And if you
yeah.
have something really, go ahead.
I bet half the people that were on your alpha team are using it as a bench device.
Oh, that's another use
Dan
case.
is,
Yeah,
I am.
yeah.
For one of them anyway.
Yeah, and then you never see one of the things I was really hoping for, and I think Mike, you'd brought this up earlier, is in a way this is really a platform, and by platform I mean it's a set of building blocks, and each building block is useful to do something, and you can then connect them together to build whatever you want to
It's
build out of
Lego.
it.
Yeah, it's a
Like,
framework.
we're seeing people come up with ideas we never even thought of,
I'll tell you one, Mike.
which is
So
awesome.
I have an electric fence. I have a garden with an electric fence because we have a lot of deer around here, and the deer love everything that you want to grow. And they don't like the weeds, but they love what you want to grow. And so we have an electric fence, and the electric fence generates some noise on 20 meters. And so I put a relay on the electric fence power supply, and I'm wirelessly controlling the electric fence. So if I'm on 20 and it's noisy, I just hit the button and turn off the electric fence.
Oh, you should do one better, George. You should get a camera that has AI included in it, and
Here we go.
if it detects an animal, it turns the electric fence on. Or put logic in Node-RED that says if there's an animal and you're on 20 meters, turn off. But if you're not on 20 meters and you see an animal, turn on.
Double the voltage.
Double the voltage. Use it as a loop on ground.
Okay, so the last module in our brief 5-minute intro.
This is like a ham radio workbench.
I know.
Workbench episode.
Welcome to the rat hole. So the fourth module there is the Wattmeter controller. So one of the things you really want to know in a remote station is how much power am I putting out? You want to know for a couple of reasons. First of all, maybe something went haywire in your system. The coax has water in it, or the antenna is, something snapped in the antenna or whatever. So you really want to know what the forward and reflected RF power is. So this controller will let you do that. This is a 2-port controller, which means you can plug in 2 independent RF directional couplers. And the directional couplers that we support off the shelf are made by a company called Wavenode. So Wavenode is a company that makes Wattmeters, and they make their own couplers, and they sell them separately. And so you just buy the coupler from Wavenode and plug it in, and it works. And so we've pre-calibrated our controller to work with 3 of the Wavenode directional couplers. So there's a HF 0 to 2000 watt sensor, there's a low power 0 to 60 watt HF sensor, and there's a 300 watt VHF UHF sensor. And so the calibration tables for those are all built in, and when you plug the coupler in, you go into the serial port and you tell it which particular sensor you're using, and then it remembers that, and you're off to the races, and it'll sample and tell you what the forward and reflected power is.
So here is the wave nodes. Can you see that?
Radio porn.
Yep. Here's the rack, the station controller in the contest rack, and that's all of it, all of its glory.
So one thing about the way you do it, Kyle, I like the way you set this up. If you're really constrained for space, and this is often not the case for HF remotes that I've seen, but for repeater sites, for instance, if you don't have the space, like the vertical space, you could mount all this stuff in like a 1U chassis and stick it in the rack, and it doesn't take up much space. The good thing about that is it's small. The bad thing about that is that if you ever have to change the wiring, it's a pain in the neck. So if you can mount things like you have here vertical, it makes the wiring so much easier, because 6 months from now, you're gonna connect a relay to something new, or you're gonna want to read another voltage, and you're gonna want to get to this stuff.
Oh yeah.
And so when you lay it out this way, it makes the working on it so much easier.
Yeah, so this is early in the process as we're laying things out, and I already have an order into some coax manufacturers to shorten up these cables. So, but I think sometimes the hardest part is whenever you have limited space in your shack, how are you going to fit something like this into it and do good cable management? You know,
Mm.
so I mean, this is early on the process. You saw a picture that I brought up, and I had a bunch of ferrites on the blue cables, the RS 485 cables. So as you work through the process and as you put things in, you'll figure out, okay, this needs to go there versus here because of these parameters, right? I only have either your cable is not long enough, or this is the most logical place to put a wave node coupler because I want it to connect directly into the antenna disconnects, which are maybe permanently mounted here. So therefore, the wave nodes have to go up next to it versus across the room. Why would you do that? Because you want to probably put all of your antenna connections all in a row or very in close proximity, so you have the shortest amount of cables, which means less loss.
And you know
There's
what,
another.
Kyle?
Good, Mike.
You really could, because of the way this is designed, put the wave nodes closer to the antenna.
Yeah.
Very, very easily, like
Yeah.
at the tower.
Yes.
So one of the things that you guys are pointing at, a really, really important aspect of the architecture. The modules are designed, the communications between the modules is designed to allow you to put them hundreds to thousands of feet apart. So there's two ways to interconnect between the modules and the computer. You could do it wired, like we see it here, which is the most common way. And the reason for using RS-485 as the data transport between the modules is, number one, I could run that cable literally thousands of feet and it'll work fine. Number two is it's relatively noise immune and it doesn't generate a lot of noise because the data rate is pretty low and it's a twisted pair, so it's somewhat self-shielding.
Yeah.
So this technique has been used for 40 years in industrial automation. It's like not an accident that they use it, and that's why it's used here. You can also put a wireless link between different locations. So for example, you can have your Raspberry Pi and your GPIO module in the shack next to you. You could put your Wattmeter module in the next room where the transmitter is with the couplers, and then you could put your coax relay 1,000 feet away by the tower to select different antennas and run one big piece of coax back to the shack.
Right.
And that works. That's it. The exact architecture is intended to do just that, whether it's wired or wireless.
Yeah, let me
Including the Wattmeter, right? You can put the Wattmeter up on the tower, which is
100%.
the best place to put it. And 485, I know, my other sports world, we've run 485 9 kilometers up a mountain without issue.
Yeah, it's surprising. And one of the guys here in Portland just put one in, and he's running 250 feet of Cat5 from his shack to the antenna, and he doesn't want to have power out where the antenna is, so he's running 12 volts down the Cat5 cable. And he said, "Is it going to work?" I said, "Probably. Why don't you try it and see what happens?"
POE.
Well, effectively the
PO Cat5, yeah.
PO Cat5, and so he just ran a piece of Cat5 out there, and it dropped like half a volt or whatever it is, no problem, and runs it perfectly fine without pulling any power out at the other end where the coax switch is. And what you're showing there on this diagram is the RF version of that. There's two different things that we sell that allow you to run the connection wirelessly between the different modules. So you can use a off-the-shelf. Go to the previous
Yeah.
diagram.
Sure.
So you could use a off-the-shelf data radio. We sell these radio modules, or you can get them elsewhere. These are 900 megahertz data radios. They actually have LoRa transceivers in them. It's
Yeah.
not mesh-tastic. It's not a ham radio LoRa thing. It's a black box, quite literally, that you put data in one end and it transmits it, and data pops out the other end. And so you could use these things, and they're license free, run at 900 megahertz. There's 100 milliwatt versions and 1 watt versions, and you could put as fancy an antenna as you want. So you could run these wireless data links quite a long distance. And as an alternative, you can also use mesh-tastic,
which I think is absolutely amazing that you put that in there. Like, mesh-tastic is now all of the rage. And whenever you put that in there, I'm like, that's a slam dunk.
So it's worth talking about this,
George.
What's that, Mike?
We played with mesh-tastic about, what, 6 or 8 months ago? Well, this is cool, but what am I going to do with it?
That's right. We were talking about like, that's cool. Why do I want this? And so we invented a reason for mesh-tastic here. So what this allows you to do is the boards that we built will let you either run cable or run the 900 meg data radio, or run the mesh-tastic 900 meg or 433 meg radios as well. Now, there's a couple of very important things to mention about mesh-tastic in this context. The first thing is, for those of you who know mesh-tastic, you're kind of jumping out of your skin. Do not run this on long fast, okay?
Oh, no,
if you don't know what that is, don't worry about it. It's a channel configuration thing. So you don't want to run this on the public texting long fast channel, right? So what you want to do is you want to create your own private channel. Maybe you want to encrypt it if you want to do that, and then no problem. Now, the other advantage to mesh-tastic is I can take my phone and I can bring up my mesh-tastic app, and I could watch the traffic going back and forth on my mesh-tastic app. Not only that, I could type a command. If I want to flip a relay and I know the syntax, the command structure, I could type that message and I could send it, and I can control any of these modules. I could read the wattage just by that. And so just one more further kind of opening your mind a little bit here. It occurred to me one day that every phone has speech to text. So I thought I could add some simple English commands to the module, and I could literally say, turn relay 1 on.
Turn relay, yeah.
And at the other end, it parses it out and goes, turn relay 1 on. Okay, click. That's
turn my flex on.
Yeah. Make QSO.
Yeah.
So
yeah. Work DX.
Here we go.
Work Vietnam DX FT8.
And let me know when you're done.
Yeah.
Submit log. So, I mean, there's really cool things you could do. Back to the platform notion. I mean, there's some really fun things you could do. I could see, for example, you might have some non-ham radio application for the GPIO module. I want to read some battery voltage, and I want to flip a relay, and I want to read a temperature, but I want to control it over mesh-tastic. I could do that. I don't need the Raspberry Pi. I don't need Node-RED. I just need my phone and the mesh-tastic module plugged into the GPIO controller somewhere, and I could remotely control and monitor stuff over mesh-tastic.
Yeah.
Holy crap! You could make your own beer. You could boil your own maple syrup, which is incredibly critical on temperature. There you go.
Exactly.
I'm trying to get more verticals open for you to sell more products.
Thanks.
Yeah.
I like those verticals, actually. I think you're onto something.
I mean, you could put this on your boat. You could do a lot of things with this.
Yeah.
I hear you.
I have a question for George. Are you done the box part of the diatribe? Because I want to bring a question in. So we've gone through a lot of stuff here, and we've really geeked out. But I know this, so I want George to answer this. Is you don't have to be a brain surgeon to make this work.
Right.
Yeah.
It is truly incredibly plug and play.
Yeah. Yeah. The easy thing is, well, not the easy thing, but the kind of easy thing is to design something technically complicated and leave it that way. And, I invented it. Surely you could understand it. I mean, that doesn't fly. So from the get-go, I tried to think about if I were a typical user of this system, what would I want to be able to do, and how do I want to do it? And I'm glad you mentioned that, Mike, because a lot of thought really went into how you set this up and what it takes to really operate it. So literally, if somebody got the system today, the Raspberry Pi has the software pre-installed on the SD card. You would get your modules and your little Cat5 cable. You would snap them together. You would plug a wall wart into one of the power jacks, and the thing would boot up. Oh, you'd have to plug in your network. The thing would boot up. It will get an IP address from your router, and it'll display it on the display. It'll say your IP address of your Node-RED dashboard is 192.168. Blah, blah, blah. And you point your web browser to that, and you've got the dashboard right in front of you. And at that point, you can start flipping relays and measuring voltages and stuff. So it is literally that easy. It's the biggest thing on the installation is like screwing the bracket to the wall and snapping the things in there, and I mean that's about it.
Well, it's funny you mentioned that. Can you see over here this orange glow? So this is a rack behind me. It's a piece of IKEA. It just holds my satellite station and my weak signal station. So my whole first version is screwed to a piece of 14-inch by 14-inch plywood with the DIN rails on it. And then I put 2 screws to hang on just hang on a screw. And it was that simple. I used to mount it all. Now it's not the prettiest looking thing. It's not as spiffy as Kyle's one, but it gives me my GUI to turn my satellite station on and off remotely, and pull it all down and wire it. So that's really nice. And the fact that it is Node-RED, which don't let it scare you. Except Kyle's added his Lightning to his, but it does make it easy to modify if you're so inclined.
Yeah.
So you hit both worlds. Out of the box, it works. I don't like it. I'll write my own.
So here's one thing I learned, Mike, in this process. When I first started, of course, there's 100 questions like, how much of this do I have to actually pre-build versus will people want to build stuff, hardware, software, et cetera. And so I finally landed on I need to ship a product that is really a turnkey appliance. And what really drove that home was in the beta testing group, we had about 10 beta testers. 9 out of the 10 beta testers are really technically, well, they're all sharp, but 9 out of 10 are really smart and have built a bunch of stuff like this before, like you guys. Okay, so Node-RED is not new to either one of you, right?
Yeah,
correct. And so I thought, well, I'll make instructions how to build the image. And what I learned was everybody in the beta was like, you know what? My words, I just want to get the thing and have it work. So even the people who are like the most capable of like creating their own version of this thing, they don't have time to mess with it. So the learning for me was what people really want is they want to get something out of the box you can plug in and use, but you want the ability to enhance it and modify it and extend it and integrate it with other stuff, maybe someday in the future.
Later.
And make that as easy as possible. But you want the thing to start working on day one. You don't want it to be like a big science project just to get the first relay to flip. That has to be like 10 minutes out of the box. You have to be able to do that.
Right.
You know what? You nailed it. Or you can hire Kyle, because I know he works for an hour late. But when I got into astronomy the first time, I wanted to see something. I wanted to see Saturn. I wanted to see them. And so I bought a point and shoot telescope, which of course all the local, no, you need to learn the sky. No, I want instant gratification. And exactly, you hit it out of the park. So thank you.
Because that's the way, I'm the same way. I mean, even as a guy who designed all this stuff, if I went to buy this, I don't want to do that. I mean, because I want to see what it's supposed to do quickly. And once I can see it, then I go, now what can I do with this thing?
You know what? And I believe you on that because I've been on the other end of those phone calls.
Yes, you have. You're very patient.
There was many times where
Kyle, you're scaring people away.
Well, I just want to show the nice thing about what comes with the station controller is you get the Raspberry Pi. It already has an OS on it, but all of the Node-RED flows are done for you. All you have to do is plug it in. and this is the back end. Granted, I've bastardized it a little bit and put my own spin because we had to integrate it into an existing flow that we had. But all of these nodes that you're seeing here, they're already done for you. You don't have to do anything. All you have to do is boot the Pi up. And George, did you preload Node Red and the flows?
Oh yeah.
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 So
So
all
the SD card is I mean, it is 100% ready to go. So it's got Node-RED installed. It's got the stock flow pre-configured with all the, you know, each one of the 3 modules is all set to go, just out of the box.
yeah. So
Right.
this
And
is what it's going to look like out of the box.
So
Okay.
let's briefly walk through this. On the left-hand side, that relay panel is the 8 relays on the GPIO module. So 1 through 4 are the little mechanical relays. 5 through 8 are the open collector outputs that go to external relays.
So it's on this GPIO. These these relays right here are the
Right.
first 4, and the second 4 are this open collector, right?
Yeah, exactly.
Yep. Okay.
Okay, then next to that, the coax switch is very simple. There's 4 positions. You can have one of 4, and you have 2 coax switches. So
Right.
it's 2 modules worth there.
Right.
And I think something else, well, let's finish. Then I want to come back to an important point on how the network works. Next to that, you have digital inputs. So the GPIO module, again, has 4 digital inputs, and you can see the 4 LEDs, digital in 1 through 4. By the way, as a dashboard, the digital inputs may or may not be useful, but if you want to add some automation, some logic that says if I'm on 20 meters, then this better be on or whatever, then that becomes more relevant.
or I left the repeater door open.
Yes. Who's done that before, Mike?
No.
Let me turn some things on here.
Oh, those are nice.
Well, the one thing while Kyle's turning this on is, if you're looking at all this, Node-RED is very logical to read. It's very easy to learn. And I really mean, if you've got a least bit of logic in you, easy to learn. And the learning curve is hugely rewarding. Like after 20 minutes of how these nodes wire together, even if you weren't using George's stuff, you can turn things on and off.
Yeah.
And you can go look, like Kyle probably, you can go look at the wiring flows, and they read like a schematic. So you can tell, hey, I did this. Where does it go? It goes over here. Whereas
It's
trying
like
to read text. Yeah.
Whenever you learn a programming language, you don't read the book and start coding, right? I mean, you may flip through, but what you really do is look at someone else's program.
Yeah.
And then you go, oh, that's how that works. And then you start tinkering with it. And then you start to understand, what you could do. Same thing here with Node-RED. So then you see.
My favorite one is, I'm getting lazy. Hey, Chat GPT, write me a function node that will read this. Okay, that's done. Next.
Or
so then,
I don't understand this error I'm getting. Chat GPT, please make my code look pretty.
Like my code for pretty, and you paste the image in of the error. Not even the text.
Yeah.
Anyway, I digress.
So then there's 3 voltmeters on the display here. There's actually 4 on the board. So there's one that is not on here. So like on things like the voltmeters, for instance, the actual hardware will measure 0 to 50 volts. And in Node-RED, you decide what the range is that you put on the dashboard. So you can say, show me 0 to 50. Now in a ham shack, 50 volts is not very useful because mostly you're looking at a 12 volt system. So you're really looking at between 0 and maybe 16 volts.
Yeah.
So like 0 to 20 is pretty typical. So it's like in our dashboard, it's preset, I think, to 0 and 20, like you have it here. And you can even change the colors, where is it green or red or all the same color, all that's easily changed. Then there's the 2 temperature probes. And then here, you can see the 2 temperature probes. I got a real rash from the guys in Europe. So one of the beta testers is Morton in Europe. And he gave me no end of grief because the first version of the GPIO module was shipped only in Fahrenheit for the temperature sensor. He's like, I don't understand what this thing is. He's joking, of course. So now, based on that, there's a switch. You can a software switch. You can switch it from F to C. Yep. So you can do that. And then the next panel over are the wattmeters. And so for each wattmeter board, there's 2 ports. Each port is for its own directional coupler. Each directional coupler has a forward and a reflected direction. So you have wattmeter number 1, forward and reflected, then wattmeter number 2, forward and reflected. Also, for the wattmeters, you can monitor just by looking at the dashboard what the current wattage is, or you can explicitly run a power test, which is what the buttons down below do. So, this is particularly useful. There's 2 times you really do this. If you have a repeater, like an FM repeater or digital repeater, you want to know what the power output is. You might want to hit the button, key the transmitter. There's a PTT output on the wattmeter module to key the transmitter. Keys the transmitter, measures the RF power, and then reports it back. Or if you're operating your remote HF station, when you turn it on for the first time remotely, you might say, I wonder what the power is. Now, it's supposed to be 100 watts, but let's just make sure. And so you might put the radio in CW, key down, run the wattmeter test, make sure it's up around 100 watts, make sure the reflected power is not too high, and you're good to go. So that's what those buttons are for.
Jody has got a question. He's been very patient and has not cussed at me yet. That was a while ago. He says, and maybe we need to do another stream on this because we're getting to an hour here and it's getting long in the tooth. If I don't put my beauty rest, I'm going to turn into a pumpkin.
The workbench or
yeah,
hour 3. Go ahead.
Yeah, unfortunately, people are not mowing their lawns and watching. If you're watching this while you're mowing the lawn, you don't need to. You need to do something else. What speed did George end up setting for the RS 485 bus, thinking that faster would be more successful? Oh my God, why can I not? Susceptible, thank you, to noise. Less tolerant of ferrites. RS 485 goes like 10K to 10 megabits officially. What's your answer, George?
It's an excellent question. The default off-the-shelf configuration is 9600 baud. And the reason for 9600 baud is it's not super slow, but it's at the slow end of the scale, which means that you'll have the greatest physical distance and the greatest noise immunity. So he's definitely on the right track about looking at the trade-offs there. For the length of the cable, there's a big trade-off. So when we say that RS-45 will go, 2,000 feet or 5,000 feet, not at 10 megabits a second. So there's a distance versus baud rate trade-off on the physical medium. So by going 9600 baud, which is fine for this application, you can go with the maximum physical length, and also you have the minimum amount of noise that's being generated. Now, having said that, there is a dip switch on the modules. If you flip the dip switch, it'll change it from 9600 baud to 115/200, so about 11 times faster. And if you want to, there's even a way to reprogram it so it runs at an arbitrarily higher baud rate. The reason I didn't make that normal is because people are going to go, oh, well, 10 megabits is better than, a kilohertz or 10 kilohertz. Let's go with that. Oh, look, nothing works. Well, that's because your cable's too long or whatever.
Yeah.
So I don't want people to like mess things up. So we just set it for 9600 baud by default, or 115/2 if you want to go that route.
Yeah.
And you're not going to notice the difference between the 2 speeds. There's so little information moving.
Yeah. So that's right. Each time the module updates with all of its data back to the Node Red thing, it's less than 100 characters. So it's pretty straightforward. And by the way, the default configuration is that data is sent in the clear, which means that you can take PuTTY or some dumb terminal program, a USB dongle, and a pair of wires, and you can clamp on to the RS-485 wires, and you can watch the traffic going back and forth in your PuTTY session, or even type a command in there, or write your own control program. So it's all very open for you to get to yourself.
Yeah.
And can I mention one other thing, quick thing? you notice like there's some LEDs on here, like which antenna am I selected? There's a green LED. The displays of the LEDs or the wattmeter or the voltmeters or the temperatures or any of that stuff, all of that stuff is displayed not because you press the button on the dashboard. It's displayed because that's what the controller tells you is going on. So let me give you an example. If I click a relay, like your let's say relay 6 on the left-hand panel, if you press the on button and then you see it flip to green, it didn't flip to green because you pressed the on button. What happened was you pressed the on button, it sent a command over the network to the GPIO module. The GPIO module decoded the command, actuated the relay, and then created a whole update packet and sent it back to the dashboard that not only told it what the state of the relay is, but what the state is of all the other 17 IO channels. So it'll come back with, here's all the temperatures and all the voltages and all the digital inputs and all the relay state, just because you flip one relay. So often you'll see from the time you press the button on the dashboard to the time it updates, it could be pretty instantaneous, or it could be a second or something like that. That latency is because you're talking to the controller and the controller is talking back to you before it updates on the screen. So what gets updated is not from the fact that you pressed the button, it's from the fact that the controller sent you an update packet, and that update packet got parsed and reflected in the dashboard, which is all the stuff you're showing there.
Yeah. And you can see all of those updates in Node-RED if you turn on the debug nodes, and you send a command, and if you got the right debug node on, which I'm trying to find.
No pressure.
Yeah, don't do math on camera. Don't debug on camera.
Just don't write code on camera.
Yeah, just don't.
And if you're wondering what a debug mode is, it's like the old school printf statement. What really happened here?
Something else that's useful while you're showing that, Kyle, is that what we've showed so far is
There you go.
yeah. So okay, let's talk about what we're seeing here. So as I mentioned, all of the packets are in clear text. Okay, the latest one there says that's an update packet from the Coax switch. So the beginning of the packet is a slash, followed by 4 characters that are from and to addresses, then a colon delimiter, and then a payload that has multiple fields, comma separated. Okay, so the last one down there, that's like the longest one we've seen. So that says from device 1, the 01, to device 0, which is the master, that's the Raspberry Pi. The following is an update packet. And because I'm saying it's an update packet, the software knows how to parse the following fields out. So it knows it's an update packet. The module type is a GPIO1 module. There's 8 bits that show you the relay state. There's 4 bits that show you the digital input state. There's 4 fields of floating point numbers that show you the voltage. And then there's 3 fields that show you temperatures. The third temperature is not installed on the module, so that's null. And then there's a space for an optional CRC at the very end. So you could literally type this in. I mean, this is how, if you're doing Meshtastic on your phone, if you want to flip a relay, you would say, 0001 from 0 to 1, RY1, relay 1, comma 1, turn it on and hit the button, and boop, that goes over and turns on the relay, and then you get this update packet back from the module.
Yeah.
So the reason why this is useful, like if you're just going to buy it and use it, you don't need to know any of this. It
Right.
just runs in the background. But if you're like a lot of us, you either want to know how something works, or you might say, I'm going to build my own module and I want it to be compatible, or I'm going to build my own control panel and I need to know the syntax. All of that's published. So in our documentation, all of the command structure is published. So you can see what every one of the modules, what all the commands are that it supports, and what the string means when it returns the value, and how to parse it out and be able to use it yourself.
Yeah. So let's take a look at that. So you created a groups IO. So if I go to the home here, it is I believe if you just type in or search for station controller in groups IO, it should come up, right?
Yeah, I have to allow you to join because I didn't want to spam it with a bunch of garbage. So right now, yeah, you just request to join and I just approve you.
And then what's great is George has created some phenomenal documentation. If you come down here to the files section.
Actually, go to the wiki because it's even easier to get there from the wiki.
Oh, look at that. And then you've got documentation, firmware downloads, the ISO images for the Raspberry Pi, shopping for third-party supplies, user contributions, and audio and video. You want to go to documentation first?
Sure.
So let's go to document. Ooh, this looks nice. Yeah, so
That's because George got tired of me phoning him.
it's like this is the Mike Walker answer. So yeah, all of the graphics are awesome. All of the diagrams are great. Unlike, don't do what I did and don't read the documentation. I think what you need to do is read the documentation first and then set your controller up and make sure that, you know, everything's
I can
plugged
imagine
in.
who would do that.
I know. It's, well, George got tired of me calling him too.
Kyle and I are the same, right? Plug it in, turn it on, and see what blows up, and then we'll figure it out later.
But George got tired of me saying these DIN rails don't work.
Oh yeah, been there.
Just
Anyway.
force it.
Worked for me.
Yeah, just force it. So anyway, the documentation is amazing. But what I want to do is you put together an amazing piece of documentation that I want to take a look at. This is great. I probably have stared at this documentation more than I have everything else. This is, if you have a flex radio or basically any radio that does these types of functions, this is how you set it up. All of your wiring is already done here. All you have to do is, you know, literally probably take the ends and either, you know, strip the ends or put a ferrule on them and crimp them down and connect them exactly where George has drawn the lines in, and connect them to the RCA jacks or the 3.5 millimeter jacks, and you're done. And it will work. I think this is a great piece of documentation.
You left out one thing.
What?
Because George sent me ferrules and I'd never used them before, I had to buy a ferrule crimper.
Oh, yeah.
Yes. Yeah. It took me 50 years to realize that a ferrule was a good thing, and it was worth the $20 for the crimper.
Yeah.
So a couple things I want to mention about. First of all, I really appreciate the comment, Kyle. I think the documentation, even if nobody ever looks at it, is really necessary because I want to be able to say, go look at this page.
Yes,
so
it is.
So
it's great documentation.
So the documentation is very important to me. That I want to make it as, on one hand, as easy as possible to get people up and running quickly, but also for the people who really want to dive in. And I've already had people ask, like, okay, I want to build my own thing. How do I make it compatible? What's the command structure? And well, there's a whole doc for that. So there's advanced documents as well. But the thing I want to mention is that we've talked a lot about flex and shown the flex here. And, you know, I use a flex. I mean, the test bed right behind me is a 6400. So, you know, all this stuff is developed around the flex in a way to start with, because that's what's so commonly used for remote. Having said that, there's nothing about this system that is specific and unique only to the flex.
Right.
If you have an elecraft or an ICOM or whatever, you know, you could equally apply it to any of those radios. So Charles, one of our beta testers, has a K4 and a 7100, and he doesn't have a flex. And so this is amazing. So Charles, NK80, he's a doctor, and he went on a trip to Tanzania. In fact, I think he might still be there. And he's operating his K4 from Africa using the station controller, and it's amazing. And so one of the things I want to do is, for common radios, is create these kind of simple diagrams, which if you look at, like, if I made 2 or 3 of them, they would kind of all look the same after a while, because it's like, okay, you need a way to turn the power on and off. Now, some radios will have like a logic input to turn the radio on and off, and others won't. And so, you know, there's gonna be some differences like that. But I definitely want to build a little library of those for a 7300, for a 9700, for, you know, a K3, K4, for, I mean, like, the list kind of goes on, with the most popular radios.
All of these connections are common connections you'd find on the back of a radio. The only connection I think that is unique to a Flex, and keep me honest here, is the remote power on.
Well, it depends on the radio. So like if a K3 or a K4 has a remote power on pin as well.
Okay,
But
gotcha.
like I don't think a 7300 does.
No.
No.
So for a lot of radios, like he is running his 7100, so that doesn't have one either. So he just has a power switch that provides DC power to the radio, and he either interrupts the DC power or turns off the AC power supply. And when the power is reapplied, the radio comes up in the on state.
A lot of these radios remember the state it was
state
in.
it's in, yeah.
Yeah, exactly.
Yeah, so if you pull DC off and put it back on as well. This is what got George to write the relay that pulsed rather than locked.
Oh, right. Yeah. So
Yeah,
Mike's been very helpful, giving me some really good suggestions. So some of the things we didn't get into, like if you get down into the commands to control the modules, like for the GPIO, you can turn relays on or off, of course, but there's also a pulse command. So if you want to just have a relay go on and off, that's a single command.
Yeah.
One of the things that's useful, there's also a long delay command. So let's say, for example, in a remote site, you want to turn your internet router, your modem, on and off. Well, you can't have a dead man switch, right? So you can't just turn off the power relay to the router, then like you're off for good, right?
Right.
So you need a way to turn the power off and back on. So if you have power going to the GPIO module, you can give it a delayed pulse command. So that'll turn the relay off, and it'll wait so many seconds, like a minute or two or whatever you want, and then turn it back on again.
Yeah.
And reboot everything.
An old swift kick in the pants.
Yeah.
James asks, and I think I know the answer, but I'm going to let you guys. Will this work through Arden Mesh Network? That's a very interesting question.
Sure, 100%.
Yeah, it's all clear text. No security on this.
Yeah, even if it's binary. I mean, so there's another mode in the DCN, the network specification, to do more of a packed binary version of it, which I'm not using currently, just because I think people want to hack it or play around with it. So I just leave it in the clear text mode, which is fine.
Yeah.
And it'll run perfectly fine. Over Arden, no problem at all.
Yeah. Don, does Sierra Wireless module run Legato? I don't know.
Let's skip that. I have an idea what it means.
Okay. Don,
but it's personal because I used to work for a company called Legato, so I don't know that there's something going on here. But ask his next question about the in series to 7300 in Unix and.
But a 7300 doesn't run a Unix variant.
I'm going to answer that.
Yeah, go.
So there's two parts here. And George mentioned this in the beginning. The command and control of the radio, or the operational part of the radio, has been handled by the radio vendors, whether it's SmartLink for the Flex World or the RBAS1 software for ICOM or whatever. So this doesn't do any of that. This does everything else, which includes with turning the radio on and off. Maybe you've invented rotator control. You could probably get into RS-232 pass-through, a whole bunch of weird terms. But this comes in where all the remote vendor software, including us, ICOM, et cetera, stops. It's the next part of the remote solution type of thing. Some radios will accept a LAN command or a cat command, so where it's not really fully shut off. It's like unless you pull power, like your TV. So
let's take that 7100 example a little further. So how would you remote a 7300? How would you remote a 7300? Well, for the radio control, like you're saying, Mike, you can use the RSBA1 stuff, or you might get something like Win4 ICOM or whatever it's called.
Yeah, there's many other ones. Yeah.
There's a bunch of other applications, and that does both the audio and the rig control stuff. The other thing that comes up a lot is, someone says, well, I could go get a web switch and turn my power supply on and off remotely, no problem. And of course, yeah, there's like 1,000 ways to do a lot of these things. So what I've really done is taken the most common things that you need to do and integrating it together, but also adding the RF oriented stuff that those general purpose things don't do, like coax switches and wattmeters and stuff like that. So it's both a integration into a single environment that's programmable and plus does more radio specific stuff.
Yeah. Mike, did you see Don's? Oh, you just
Yeah, I
answered.
did.
Yeah,
Well, so let's throw it in charge.
Yeah.
Fire away.
Legato is a Unix variant that Sierra Wireless uses in their embedded radio modules. I'm working with it at work, Don says.
That's Sierra Wireless.
Yeah, so Sierra Wireless,
the modem company.
Yeah.
Yeah. So I don't quite know what the question is.
I don't know if there is a question there, George.
Oh,
I think it was just a statement.
I'll just skip on it.
Yeah.
I know what he means now.
Yeah.
Beyond the scope of today's call.
Yeah. And Paul says I can turn the 7300 on and off through WF view.
Yeah.
Sure.
Yeah.
Yeah. So if what you want to do is like do one thing, you could do it with this, but it's an expensive way to do it. This is really if you want to do a whole bunch of things like a complete station remote control and monitoring solution. It's really what it's intended for.
Yeah. Yeah. Page 2 and 3 on your guide here shows a few other things. Again, how to monitor the transmit state of your radio. A lot of radios have TX out, right, to drive an amp, Also, whenever you key down the transmitter, I believe this last screen that we're taking a look at, George, keep me honest here, this is where you could key down and then you could key the RF meter, which then would read the forward and reverse power out and give you a reading.
That's exactly right.
And you know how we're going to use this? This is what I was thinking about. We have yet to put together a baseline of all of our bands and all of our antennas. So therefore, whenever we are contesting or we're doing something and an antenna goes wonky or, we have an anomaly, we have a baseline to say, wait a minute, that SWR looks greater than it was last week or the last contest weekend. And having that baseline, and what we're going to do is we're going to run a Node-RED script through it at 3 o'clock in the morning. It turns on all of the radios. It changes all the frequencies. It selects all the antennas and just puts 5 watts through it and tells me what the SWR is. And do I have enough, am I putting out 5 watts? And just do that baseline. And if you do that once a week, then you can start plotting that graph to say, wait a minute, 2 weeks ago we were a 1.1 and now we're a 1.7 on 20 meters on our XR5. Something's going on there,
Yeah, that's a really, really good idea. I think I'm excited to see what sort of stuff we can do like you're describing on top of all this. This becomes kind of the platform you do that on top of. And what you described is actually super useful if you use this in the context of a repeater system. So if I have, let's say I've got a repeater, I've got a 100-watt repeater. Well, when I install that thing, I'm going to measure it and I'm going to see 100 watts forward and maybe like 1 watt reflected and like I'm good to go. I want to constantly monitor that. And if I ever see the forward power dip down below a certain threshold, or if I ever see the reflected power go above a certain threshold, I want to get an alert. I mean, I want to know, because if you're driving around, let's say you get some water in the feed line and your SWR goes up and you're driving around, the repeater still sounds fine until it really starts to crap out. But I want to know that the SWR is really high so I can go fix it before it takes out the final.
Yeah.
So I, that's another example of what's really useful about this for even non-station.
Or break the push to talk line to the amplifier to trip the amp off, or
Yep.
Yeah.
This is where you get in one of those Node-RED nightmare or rat holes at 2 a.m. going, hey, I can do this.
Yeah.
But the point is,
Yeah.
you can do this.
I was thinking also that this station controller with all of the Node-RED behind it would be great for hams that are blind, because all of that information is just right there. So therefore you can get audible alerts, and you can get all of the things that you need. We've got a couple of blind hams here in St. Louis, and I've gone over to help them, put together the station. One of them finally got a flex, and I set up their Node-RED, and now they're getting audible alerts whenever their SWR is high. Never
that's
before
great.
were they able to do that.
That's
they were
a
just
fantastic use case. I love that.
they were just transmitting whenever, the SWR was like 2.5 or 3 to 1, and they blew up an amplifier and they didn't know it. Well, I went over and just like, we can solve this, and we solved it with Node-RED.
Wow.
That's really cool, because you can add some kind of audible
Yes.
alert, right? So if something's in a bad condition, you can have the computer make a noise, or you could even do something like you just take a buzzer of some sort, hook it up to one of the relays, and in Node-RED you just say, well, if the reflected power is more than, if antenna is on port 1 and the reflected power is more than 10 watts, then close this relay. I mean, that's a really easy thing to do in Node-RED.
Right.
You
and
can
turn on
actually
the
have
alert.
Node-RED say, play a wave file and say, trouble, Will Robinson.
Danger, danger.
Or even more specifically, what the wattage is. So, by the way,
or the wattage power.
You're bringing up a really cool application. So I created, for our repeater control systems, I made a voice library. And the idea for that was, if you're doing measurements like this, that you could stitch together a sentence. And so I wrote a little Python program that you just send it a command. You say Python speak, and then a series of words. And each one of those words corresponds to a little wave file. And so you can, if you're measuring, 10 watts reflected, you can just create a simple command that's like Python speak reflected power 10 watts.
Yeah.
And I already have that. I mean, if somebody wants it and wants to play around with it, I'd give it to you. So that's a great idea.
I'm going to look at the audio out right now in the as a flow. Is node flow node?
There is an audio out, isn't there?
Oh, there is. I've used it before. When people would connect to the remote station, I would say, plays whatever you want it to play. So I'm looking at it. It actually does a TTS voice. So I might actually hear it while you're talking. I'm going to try it. So carry on. We'll come back.
Okay.
All right. We've been rapping for an hour and a half here. It seems like I
don't know how
hit
that
the stream
happens.
button. I'd like to get, we never got to my goal, which I'd like to go through the DCN network. And so I guess, George, you're like a bad girlfriend. You left something at my house, and now you got to come back and get it. So we're gonna have
that earring under the couch.
Yeah, you're gonna have to come back on the stream and talk about the DCN network.
So do you have like 2 quick questions? Maybe we can just tease the topic a little bit.
I don't have any questions about the DCN network. I think the hardest part that I had deciphering the network was I kept getting hung up on the to and the from. And I figured out that the to was obviously in every single board. Let's talk about this for a minute. Every single board is got a unique address, and that is set by the dip switches on the actual board. But whenever you ship out all of your controller modules, they're automatically set. But if you get something additional, you need to make sure that that address does not conflict with an address that is already in your system. So for all of the people that are going to make their own boards, and this thing grows to something that is uncontrollable, and everyone is like, now it's the station controller framework that we're dealing with. You need to make sure that you have dip switches or a way to address your module. So therefore, I can make it number 4 or number 6 or number 10 in the series to make it unique, right?
That's right. So just to kind of double click on that, the boards have 8 little dip switches. 4 of those dip switches are reserved for the address, and 4 of the dip switches are reserved for specific modes that you might want to turn on and off. Like on the Wattmeter, there's a dip switch to turn it into streaming mode that'll just constantly send Wattmeter measurements, so you don't have to ask it. So 4 of them for stuff like that, and 4 for address. So if you have 4 bits for address, you have 16 addresses. The master controller, the Raspberry Pi computer, whatever, is always address 0. And that means you have 15 addresses for modules.
Yeah.
So you can have up to 15 things in your shack by setting those dip switches. By the way, the protocol will support up to 99 addresses, and you can actually override the dip switches through the USB port. So there's a command. If you go in the USB port, you can say you are device 57. And it'll store that in its flash memory, and it knows when it boots up, it's address 57. So that's like a corner case advanced feature, because how many people are going to need more than 15 modules? I hope a lot.
Yeah,
I mean,
well,
I hope that's true.
You never know.
You never know.
But it just for the layman, if here I've got, can you see that, George? Can you see the screen here? So we've got the address here on the left-hand side, and we've got, starting over on the left-hand side, we've got 8, 4, 2, and 1. So if I wanted this board to be address 1, I would take this dip switch and I would turn it on, correct?
You'd flip it up.
But if I wanted this board to be 3, I would have to add 2 plus 1. So I would have to take this dip switch and this dip switch and turn it on.
Correct.
So that's how it works, right?
Exactly.
Okay.
And if you flipped all of them up, that adds up to 15. That's how you get the highest address.
Oh,
you just switches.
You just did math on camera. That's great.
That's from memory. So, if you want something bigger than 15, you go through the USB port, and there's an address command that says, henceforth, your address is now 25.
Oh, gotcha. Okay, yeah.
Now, the reality is that very few people are going to ever have more than 15 modules. And if you did, you're probably going to run multiple physical networks.
Yeah.
So that's a thing.
Now, does your data network, does like, if you do this over LoRa, does your devices there have to have addresses too?
Yeah, just think about it this way. In any network, logically, all the devices are sitting on the same channel, physical medium. And so the main controller, the Raspberry Pi, and up to 15 things are connected together. Whether the interconnection is a 6-inch piece of Cat5 cable or 20 miles away over a data radio, it's all the same flat network. It doesn't care or know, frankly, where it's located.
Yep.
It's all logically one network.
And then the DCN network, I learned this crash course. I had to get my baud hat out because I had a brain fart, and I called George. I'm like, this isn't working. And then he's just like, you idiot, it's a different channel. Everything first is 9600 baud, like we talked about. But there is, talk just a quick minute about, you can put the Wattmeter in streaming mode, and you can bump up that to 11.5200, and then that becomes, you have to make sure that the things that are reading the RF meter are communicating on that baud, because if you all of the other things are going to be still at 9600 baud, and it's going to throw the whole thing out of whack if you don't make some changes to your system.
Yeah, that's right. So the way the system is designed, to use it in the standard simple mode out of the box, there is one interconnection between the computer and all of the modules. It all runs at 9600 baud. It's controlled by the main dashboard. And that's the simple way to think about it. Out of the box, it just does that.
Yes.
Now, there's a whole bunch of options that you can go into. And I don't talk about these options a lot up front because I don't want to befuddle people.
Yeah.
It's like, wait a minute, you just brought up 16 things. I don't even know what, So once you start using the system, then you might want to do some things that are more advanced. And so that's what you're really pointing to, Kyle. So for example, one of the advanced features is to switch from polling mode, which is the default, to streaming mode. Now, what is streaming mode? Streaming mode is where, well, first of all, what is polling mode? Polling mode is where the main computer says, okay, device number one, what's your status? Okay, here's the status, I'll update the dashboard. Device number two, what's your status? Device number three, what's your device number four? So it round robins through the 2, 3, 5, whatever number of modules you've got and updates the dashboard periodically, or anytime something changes, it updates the dashboard. That's
okay.
polling mode.
Yep.
In which case the main computer is always in control. Streaming mode is different. Streaming mode, the devices will measure all of the sensor inputs and send the same data you get when you poll, but just shoot it blindly back to the master. Like for the Wattmeter is a great example that you bring up. In streaming mode, the Wattmeter will sample the RF sensors, both of them, as fast as about 2 or 3 times a second, and send that data in bursts, constantly banging back to the main computer. Now, why would you do that? Well, if you have, let's say you just want to see what's your power output today once, then the normal command round robin polling is fine.
Yep.
But if you want to dynamically watch the Wattmeter bouncing around, then you need to get a lot of data. And you can't do that while you're polling the other devices without a bunch of collisions. And so what you do is you create now 2 networks. You have one network for your GPIO module and your Coax relay that you're only touching very rarely.
Right.
And then you've got a separate physical channel that is streaming data from the Wattmeter constantly. So to make that work, on the computer side, you take a little USB dongle, you plug the USB dongle in, it enumerates as a new COM port on the computer, and you might as well set it to a higher baud rate, so like 115.2. So you flip a dip switch. There's 2 dip switches on the Wattmeter module that'll do this. One dip switch changes it from 9600 to 115.2, so it's 11 times faster.
Yep.
Another dip switch puts it in streaming mode. So now I've got all the same Wattmeter data going out a different wire, headed towards the USB dongle on the computer.
So it's
the only thing,
it's not through, just to make sure that everyone is clear, it's not through the cables that you originally plugged into, the blue little cables. This is a separate cable that you need to make, that you get the USB dongle and you tie that into a port, the top port, one of these system ports. So you guys aren't seeing this, but anyway, a top port, you've got an A and a B, right?
Right.
And you tie that into the USB port, then you plug that into your Raspberry Pi, and then that becomes another input that you're constantly getting data from, right?
That's right. So on a Raspberry Pi 3, there's 4 USB ports. So you just take that dongle, stick it into one of those ports. And so what happens in Linux, when you plug that in, the default UART that we use for the network is, for you Linux guys, is /dev/ttys0. When you plug a USB dongle into the USB socket, that enumerates as /dev/tty/USB0. So what do? You go into your dashboard, and instead of looking at the dashboard, you go into the source code version where you see all the flow stuff. You go to the tab that's the Wattmeter tab, and in the very beginning of the whole flow is where the serial data comes into the flow. That little object on that palette of the program is set to talk to the normal default UART. So you just bring that panel up, you change it to TTY USB 0, and now that logically is connected to the new wire that's going just to the Wattmeter. And then on the dashboard, as your RF power goes up and down, now your RF meter is going to be bouncing around, a couple times a second, to keep up with the modulated signal on the wattmeter.
Yeah. So you're going to see 2 serial ports whenever you go into that DCN network. You're going to see, or into into Node-RED, into your serial devices. You're going to see two entries. That second entry, that first entry is going to be made for you because that's going to come with Node-RED. That second entry, you're going to have to manually create and associate it with that new USB.
So it's actually even easier than that, because
Oh, it is?
because let's say you have the GPIO module, the coax relay, and the wattmeter.
Yeah.
Out of the box, don't do anything. Snap, plug it together, boot
Right.
it up, it just runs.
Okay.
And you're in polling mode. And you say, okay, that's all fine, but I want my wattmeter to be fast, and I want to see it constantly updating. All you have to do is plug in that USB adapter to the wattmeter, unplug the wattmeter from the other network. Right?
Okay, gotcha.
Plug in the USB.
Oh, yeah.
You go into your Node-RED program, and you bring up the panel for the serial input to the wattmeter part of the flow, and you just change that to TTY USB 0, and you're done.
Yeah, gotcha.
And
That's the easy way. Yeah.
And it just works.
Yeah.
So and there's other features of other modules that we're not getting into at all. Like in the GPIO module, there's a whole data acquisition mode where you can go into any of the analog measurements like voltmeters and stuff like that. You could turn on triggers that say, if I ever go above or below a threshold, send an alert from the module, not just even in Node-RED, but even from the module. So there's all kinds of advanced features that we're not even touching yet. So one last thing I think that's very relevant at this point, and that is, if the thing comes pre-configured for those 3 modules, it just works off the shelf. But what if you get a 4th module? So like you had to do, Kyle, you have 2 coax switches. Well, what do you do? And it's as simple as you go into the coax module page, you lasso that thing and you copy it, and then you go in and you just change its number in one of the little modules, and then now you've got a second a coax switch, or a second wattmeter module, or a second GPIO module. So the nice thing about Node-RED is it's like a 2-minute job to literally go in, take whatever module you're just installing a second one of, take that source flow, copy and paste it, change the address, and you're done. And now you've got a whole new module installed.
Yeah. That's the great thing about Node-RED is, and I would assume, because I'm no coder, is all of that stuff, once you get it working and you want to add on to it, you just, like you said, copy and paste, and you just change the address, and it just starts to work.
It just starts to work. You may have to go into the layout editor and move the objects around on the screen where you want them, but it's, that's easy, and that's very cosmetic. So that's kind of the simple thing. So extending this with, another 3, 4, 5, 8, whatever modules, or creating multiple physical channels, or running at higher data rates, all those things are very easy to do, and are kind of like for bigger, more sophisticated installations.
Yeah. Don says the streaming mode, we call that telemetry data.
Yeah.
The old industrial, or the process automation.
So a lot of guys who will see this, who are industrial automation professionals, will see a lot of similarities to their world. So, DIN rail, physical stuff, RS-485, polling, streaming. This is not like an accident.
Yeah.
Because when I was looking at, how should one build something like this, a lot of the thought that went into it was like, well, what are the best practices from, traditional industrial automation that why reinvent that wheel? We might as well use those same techniques, but do it in a way that's approachable as hams. Because the flip side is, you don't want something to come off as like, okay, here's a professional piece of hardware that you got to take 30 hours of training to learn how to use. Then that's not going to cut it.
Yeah.
So, how do we make it both an easy to use out of the box experience, but also build it in such a way that somebody who's even kind of a professional in the field could say, okay, I get all this, and I could see how to use it and how to extend it if I want to.
Yeah. Well, I mean, you have nailed the nail on the head with taking this thing out of the box, plugging it in, and just making it work, which is a lot of what hams just want. They just want it to work, and It's
Me
great.
too.
Yeah, there's nothing more frustrating than getting something new and you know what it does because you've watched a bunch of YouTube videos on it, and you're excited to get it up and running, and then you have to read 3 hours of manuals to get it up and running.
Kyle, I learned something the hard way many years ago. I built some ham radio products, and I thought, well, most people who are going to buy this stuff are going to want to dig into the technical details. And what I learned was there's kind of two kinds of hams. It's always a difficult thing when you generalize like this, but there's sort of two kinds of hams, and I think all of us have a little bit of both in us. One mode is where you say, look, I have a problem and I want to solve that problem, and I just need a thing that solves the problem. I really don't care how they solved it. Like when I buy a radio, honestly, I'm curious what's inside, but it's not going to make a difference to me.
Yeah.
Like what microcontroller did they build into the Yaesu FTM 500? I don't care.
Well, I just want the clock to tell time. I don't care how it does it. I just want it to make it sure that I can read it.
So
right?
That's mode one. Is
Right.
I just want to solve a problem. Just give me
Right.
the thing that solves a problem. Mode two is I'm really technically curious, either because I just am, or because maybe I'll want to build something kind of like this and I want to learn something. And I just want to know how it works.
Or you want to make it better.
Or I want to make it better, or I want to build my own version of this. Or like when I buy a lot of geeky products, I tend to gravitate towards the ones that I know that are extensible. Like the reason a flex radio is very appealing to me is that out of the box, it's a really great user experience, but it's got the whole API. I may never use the API, but the fact that it's there is kind of cool. Like, besides which, I may never use it, but I'd love to know how that works.
Yeah.
And so that when I say there's two modes, it's like I need a black box that does a thing. Thank you very much. Or how does that work?
Yeah.
And so I want to be able to, kind of scratch both of those itches with this product.
Yep.
I wish I had this, George, when we first met and I was buying your repeater controller.
I wish you did too.
Because we'd have been in a whole different world.
So Mike, I know you really appreciate that. If you look at this whole station, you can sort of see in it, coming from the repeater owner's perspective, how a lot of the features in here are like, man, I wish I had that on my repeater system.
How many trips to the hill would this have saved?
Well, exactly.
Hundreds.
So, and this is kind of the industrial IoT kind of aspect of ham radio, where if you're a repeater owner and it takes you 4 hours to get to your repeater site, if you're lucky, and you get up there and you find out, oh, I wish I had brought the whatever. What I want to do is I want to instrument the vitals of my repeater. So if in the morning when I press the pickle, nothing happens, what happened? Did the antenna fall off the tower? Did someone disconnect the coax? Did the power supply fuse pop? Did the PA burn out? I don't know what's, all I know is it ain't working. And when you get there, it could be any of those things, right? You could get up there and go, holy cow, someone stole my coax. I should have brought 100 feet of hardline. Like, how did I know that? I didn't know that.
I want to turn the transmitter off because we're being hacked today.
Well, and the cool thing is, since
which you're supposed to be able to do anyway.
Yeah,
true.
Well, we're in the process of putting a Arden network in. So it would be very easy to get on that Arden network and just take a look at the vitals of the station.
Yep.
And today we do that over the internet, and we have a VPN, but still you got to log into the VPN. You got to figure out your username and password. Be cool if I would like to broadcast this over APRS, and be able to monitor it through APRS. But we have this thing called Arden that is a little bit better than APRS. A little bit faster. Let me say that. It's faster.
Instantly, one of the other reasons why the default data rate is 9600 baud is that it's slow enough that you could, even if you had maybe not your remote station, although you could do it, but if you had something that was remote, like a repeater even, and you want some sort of physical control over it besides the usual DTMF through the repeater controller, you could just use a TNC. You could put a TNC on the ground and a TNC at the repeater site, and you could just pump 9600 baud DCN data through the TNC. It'd work fine.
Yeah. Don says packet BBS. You could literally flip relays coming up on 2 hours. I think the pumpkin has already exploded here. We're all gonna turn into Cinderella. Is there anything else that we want to? Oh, you would okay. All right. Hang on. Let me make you
So
big here. Hang on.
okay,
Okay,
yeah. So
there you
last little
go.
thing. So when you build something like this, there's always a very long list of ideas that you may or may not get around to. And like I mentioned earlier, I'm working on a VHF coaxial switch. But another thing that came up was it'd be nice to have a DC power control relay, and otherwise I have to go get a relay and figure out where to put it. So there's a new module. I just got these today, actually, from assembly. So it's the usual DIN rail clip with a insulating base plate. And so you've got a pair of power poles and a 30 amp relay. And you just need 2 wires to go to the open collector and 12 volt out of the GPIO module, so you can turn your power on and off. And there's a little status LED, and there's also 2 probe points pre-wired. So if you want to measure the input and output voltage and wire one or both of those back to the DC voltmeters of your GPIO module, you can do that. So
This is great.
So there'll be a string of little things like this that come out over time.
How many did you get?
How many do you need?
I'll be in Austin. I'm going to be in Austin in a couple of weeks.
Oh, I'll let me know. I'll send you some. So, and they're skinny. I mean, so you can really snap a bunch of them together, and they don't take up a whole lot of space.
It is your own little what is that thing by West Mountain Radio that is
Rig Runner?
that is always out of stock.
Yeah, it's the baby Rig Runner.
Right, the 4005i. You solved it right there.
There you go.
Yeah, we've been waiting on one of those for one of the repeater sites for 3 years. So looks like we just solved it. You just solved it. So, all right, very good. Anything else, George, that you want to?
I'm going to be at Hamvention. So, so by the way, all the stuff that we talked about today is all for sale and shippable now. I'm filling orders, so just go to the website. But I'm also going to be at Hamvention. I'm going to bring all this stuff there, as well as Pactenas. And then after Hamvention, 2 weeks later, I'll be at CPAC in Oregon.
Oh, nice. George is also going to. George, are you going to come to the Node-RED forum and do a little talking too?
I'd love to. Yes, I definitely will be there.
Yeah, so I'm going to do a Node-RED forum at Dayton, and I don't know when it is. They haven't figured out when the my forum is at, but I'm sure that whenever I figure that out, I will announce it. And then also, Mike, are you going to do the remote ham radio forum again this year?
I think you're one of my guests, aren't you, for that?
I am. I don't know that.
Sure. Good thing we had this call.
I think actually I'll have to check my emails. I'm pretty sure I thought we were going to do it.
Oh, okay. Had no idea.
You've probably forgotten.
You
were probably a little distracted back then. Yeah, I think we agreed that you were going to come into that.
Okay.
But I'll be speaking at Dayton as well. And Kyle, in your show notes, I want you to put a link into the Node-RED amateur radio group.
Okay.
Which is all about everything Node-RED for ham radio operators, including, there's a bunch of stuff to get in case you want to get started in it, and lots of help there too.
Okay, got it. I'm adding it right now. You guys want to talk about ham radio workbench, in case the 400
simulated it.
the 400,000 hams that don't know about ham radio workbench.
Yeah, so we do a podcast. So Mike and I and some of our friends do a ham radio podcast every 2 weeks, Ham Radio Workbench. We're up to episode 230 something. We just did a really cool episode with Patrick, who owns Geocron. And we did that not only as an audio podcast, which is normal for us, but we also did that as a YouTube video. So it's pretty cool. You get the whole backstory.
The whole history, I'm going to plug that because that was a great
ahead.
story. The whole history of Geocron. And what an interesting person.
Wow. I was watching my friend Bill do some streams on Geocron, and I had no idea that it could do weather. It could do a whole bunch of there's just plugins after plugins that you can get for that. I I thought it
I-
was just the
I'm-
sun.
I-
Across
I'm
the
looking
screen.
at mine right now, Kyle, and I have a layer called weather, and I'm seeing all this looping blue snow and freezing rain and green, and zoomed in on just on the United States. It's on the Atlas 2B. There's newer hardware, but yeah, I paid him for his whole advanced premier programs. It's $100 a year or something, and I'm happy to pay programmers because I want this every year. So.
Yeah, it's really cool. It is really neat. I
Yeah.
had no idea that it could do all that stuff, so I was very impressed. So yeah, be
Yeah.
interested to.
And also Patrick is a really cool guy, and it's nice, when you the nice thing about ham radio is a lot of times the vendors. I mean, personally, and they're a little company. They make a really cool product, and really nice guy. So it was a delightful interview. So we've got a whole bunch of fun episodes. We mostly talk about going deep on technical rat holes on a variety of topics, and most of us are avid either like normal operators or portable operators or something. So we have Thomas K4SWL and Vince VE6LK and Mark N6MTS, Rod VA3ON. And Mike and myself, and so usually there's at least 3 or 4 of us there on the show. We talk about what we build and our projects, and then we have guests on and we talk about cool stuff like you, Kyle, coming to talk about field day and networking and contesting stuff.
Yeah,
So
it's a great podcast. I really like not only the guests, but I really like listening to you guys rap about what is on your workbench, because not only are you talking about what's on your workbench, but you're giving us ideas of the things that you might mention something that I don't know anything about, and then I've gone down the rabbit hole on YouTube about said topic, and I'm like, I had no idea
Credit
that.
card comes out.
Right, exactly. I mean, your Black Friday shopping show, forget about it. Like, I mean, I literally every single year I'm spending $300-400 just on myself because I'm like, I had no idea that existed, and then I go on the internet and I'm like, look at this help, the helping hands, the adjustable helping hands. I forgot what that's
Oh,
called.
that thing was amazing.
Yes. Yeah, I got exactly. I got one on my workbench because I had no idea that existed, but I went out and bought it because it was.
We sold him out.
Yep.
Oh, really?
Yeah.
Wow.
OmniFixo.
OmniFixo. That's what it's called. Yeah. Yep.
Well, one of the things that we tried to do in the show is not just kind of BS, but we there's plenty of that, but we
We're
try
really good
to really make an effort to bring something new, some new discovery, some new technology, some new product, some new operating thing, whatever, so that people are not just like you just sat around and talked about stuff I know about. I mean, so we try to bring in interesting topics, and then also bring in experts. Frankly, between just us, I think we figured out, Mike, one time there's like 120 ham radio years of expertise in the crowd, but then we bring in experts who really know a lot about propagation or radio design. Like we've had people from Elecraft, from Flex, from propagation folks come on, you guys building QRP radios and kits and all kinds of stuff. Anyway,
yeah,
so
it's great. I put the OmniFixo link in the chat. They were asking for it. Great.
Very good.
We just sold them out again, maybe. I don't know. All right. Anything else, guys? Have we?
Well, thanks so much. Thanks so much for having us on. I mean, I really appreciate this, and I would love to go nerd out even more on diving deeper if you like.
We will. We'll have another stream here, and we'll talk about the DCN network, because I think that is, I want to get into a deep dive of that and understand that. So therefore, if somebody wants to write their own module or design something, that they understand what the protocol is, and what all of the different syntax means.
Mm-hmm.
I think that would probably be for nerds like me. That would probably be a good a good episode, and I'm pretty much doing that episode for me, not anybody else. But if anybody wants to show up, you're more than welcome. All right. Very good.
Kyle, thanks for letting me crash the show tonight.
You're welcome. Thank you for showing up. I I haven't seen you in a while, so I missed you at Hamcation. So it'll be good to catch up at Dayton with
Oh,
you.
because you weren't there. Yeah,
I was not
that's
there.
right.
You were there though.
Yeah, I was there. Yeah.
You were there, standing all day selling radios and doing forums, right?
Hold on just for a second. If you
Sure.
hung in this long, so I'm going to back Kyle up on why we were late. And your choice was to either have this audio or have this audio. Is it still bad?
Yeah, it's
Yep.
back bedroom.
Okay, we'll go back to this audio.
Yeah, we were trying to fix Mike's audio, and looks like he's got a glitch in the matrix. So, all right, very good. Thanks everyone, appreciate it. Thank you, George. Thank you, Mike. And yeah, everything is in the show notes below. I put all of the Discord and the link to the station controller and ham radio workbench and Pactena and all that stuff in the show notes. So go out and check it out. If you are still watching, you're a trooper. Thank you. And we'll catch you later. 73 guys.
73.
7-3.